Hi, boys and girls. It's Miss Manning. I'm going to be teaching you Module 2, Lesson 6, where we're learning to connect the area model and the distributive property to partial products of the standard algorithm with renaming. So it's going to be the same steps as yesterday. We first have to distribute or break apart our factors, and then we're going to think about them like we're measuring the area of a shape with length times width. And then we're going to take those partial products that we get in the area model and we're going to add them back together to get our final product. All right, let's go ahead and get started with some mental math, remembering what we did yesterday. So we have 243 times 12. If I'm looking for which number makes most sense to break apart, it's going to be breaking apart this 12 because I can break it apart into taking 243 times 10 and also 243 and doubling it, taking it times 2. So it makes most sense to break it apart that way. And I'm going to put the 2 first because that's our ones place. And then I'm going to put a 10 and I have 243. So first I have to start with the length of this shape and the width. So 243 times 2. So basically I'm doubling this number. So 3 doubled is 6, 4 doubled is 8, and 2 doubled is 4. So I get 486 for the area of this. That's my partial product there. And then I have to take 243 times 10, which means that this 2 here in the hundreds place is going to jump over one place into the thousands. This 4 in the tens is going to move to the hundreds, and the 3 and the 1 is going to move to the tens. And that leaves me with a placeholder 0 in the ones place. Now, the third step is to add those partial products together. So I'm going to start in the ones place, and I get a 6. I'm going to then go to the tens place. So I have 8, 9, 10, 11. I'm going to carry a 1, and I end up with 9. And then in my thousands place, I have a 2. So 2,916. Let's double check that with the standard algorithm. So I'm going to write out 243 times 12. And I'm going to start off here multiplying the ones place. So 3 times 2 is 6. 4 times 2 is 8. 2 times 2 is 4. If you look, those two numbers are the exact same. Now I'm going to go on to multiplying by the tens place. So 3 times 1. I forgot. I'm in the tens place, which means everything would be moving over. So I need to have that 0 to say that I'm not just multiplying it by 1, but I'm technically multiplying it by 10. So 3 times 1, 3. 4 times 1, 4. 2 times 1, 2. So again, I end up with the exact same partial product, and now it's time for me to put my partial products in the standard algorithm back together. 6, 11, 9, and 2. 2,916 is our final product for that. So up until this point, we've been multiplying by relatively simple numbers. But now we need to start talking about what we're going to do when we come across numbers bigger. If I were to decompose or distribute one of these numbers, let's say I do it to 64, and then I'm left with 73. I can't multiply 60 times 73 very easily in my head, nor can I multiply 73 times 4 very easily in my head. So we have to think about the fact that we might have to break apart our numbers a little bit more. So in this case, when we break apart 64 and 73, it should look like this. So we've ended up breaking apart both numbers. And so what we're left with is 4 different rectangles to find the area of. So we're now on step 2 where we're finding the area. And then when we finish this for step 3, we'll have 4 partial products to put back together. But we can put together partial products going across. So kind of just breaking it apart and then putting them back together relatively simply. So first we have 70 times 4. 7 times 4 is our basic fact of 28, and it's a power of 10. And then we have 4 times 3, which is 12. So now I'm going to go ahead and put those back together and get 292. Then we go down here And we have 70 is our length, and then we have 60 as our width. So our basic fact is 7 times 6, which is 42. Then I count my zeros, 2 zeros. Then I have a length for this rectangle right here of 3 and a width of the same width of this rectangle, which is 60. So my basic fact is 6 times 3, which is 18. My power of 10, or my 0, goes there. So now I have to put these two together, which should be pretty easy. In the ones place, I have a 0. In the tens place, I have an 8 and a 0, so I have an 8. In my hundreds place, I have a 1 and a 2, giving me 3. And then in the thousands place, I have a 4. So now I have, again, two partial products where I did have 4. But instead of lining up 4 numbers to add, we're just going to go ahead and line up the 2 numbers. So I have 2 plus 0, 9 plus 8, carry the 1, 2 plus 3 plus 1, and my thousands place. So 4,673 is our product for that one. Now we're going to go ahead and we're going to do the standard algorithm for this problem. Make sure that our area model, we can connect it to what we do for the standard algorithm. So I have 64, nope, I'm going to put 73 on top, times 64. So what we're looking for is for these two numbers to be the same as what I get when I'm multiplying. So first I'm going to go ahead and I'm going to just focus on this 4 here. I'm going to take 73 times 4. And it's going to be a little bit backwards. If you notice, right now, my first step in the standard algorithm is 3 times 4, which is what I had for this rectangle here, 3 times 4. So I actually have a 12, but because we're doing it the standard way, I'm not going to put two numbers in one place value. So I'm going to go ahead and carry that. And then I'm going to multiply 7 times 4, which is 28, plus 1 more, 29, which ends up being the same number that we got here. But if you look, when we did that second step, we were multiplying this, the same thing that we multiplied here. The only difference is instead of waiting to add, when we added the 1 and the 8, we went ahead and did that right here. So if I would have taken, this is technically a 70 times 4, I would have gotten 280. And when I took 3 times 4, I got 12. So what I was able to do was put that together all in one step here. Now we're going to go on to taking 73 times 6. And the first thing that I'm going to do is I'm going to take 3 times 60. So it's not really just 6. So I have my 0 here. So 60 times 3, that would be what I would be doing in this box right here, this area. I'm taking 60, which is the width, and then 3, which is the length. And we get 18, and I'm going to carry my 1 up here. So we should get 180. A lot of times kids want to put that 1 down here and then just keep carrying on those numbers. But actually, it's just like it being a partial product here. That 1 gets added to this 2 eventually. So that's why we end up just carrying it up here. And now I have the 7, which is a 70 times 60, which is what we did in this box right here, 70 times 60. And that's 42 plus 1 more, 43. So if you look at this partial product here, it's the same as our partial product right there. So now I get to put my partial products together, 2, 17, 6, and 4. And I end up with the same product. All right, for our next problem, I'm going to go ahead and I'm going to leave this area model blank for you. I want you to pause the video and solve the area model for this problem on your own. So you're going to go ahead and decide how you distribute or break apart. So the first thing you're doing is breaking that apart. Then you're going to, for each rectangle, find the area of that said rectangle. And then you'll have partial products for the third step to add together. So after you unpause the video, I'm going to solve the problem with a traditional algorithm, and then we can compare your area model to the traditional algorithm. So go ahead and pause your video now. Okay, so now I'm going to go ahead and solve 624 times 82. And let's go ahead and start with our ones place. So 4 times 2 is 8. So I'm going to do that first. Now I'm going to move on to multiplying the tens place times the ones place. So 2 times 2 is 4. And now I'm going to multiply the hundreds place times 2. 6 times 2 is 12. All right, now let's go on to the tens place, which is an 8 or 80, which means that I'm going to end my answer in 0. So the first number that I would multiply is the ones place times the tens place. So 4 times 8 is 32. I'm going to carry above the next place value. So I carried it above the tens place because that's what I'm multiplying next. So I have my tens place times my tens place. So 2 times 8 is 16. And then I add my carried number up here. So I have 16, 17, 18, 19. And then I need to carry that 1 to the next place value, which is the hundreds. And remember, I add that after I multiply my hundreds place times the tens place. 6 times 8 is 48, 49. 6 times 8 is typically a problem that I have students struggling with when when it comes to basic facts. And I always like the distributive property for this one. So you could take 6 times 4 and 6 times 4. Typically, kids tend to know 6 times 4 basic fact. So all we did is we broke apart that 8 into 2 4s. And then once we have those partial products of 24, we put them back together. Another way that you could think of it is you could break apart this 6 into 3 and 3. So I would have to take 3 times 8 and 3 times 8. And then I would still get 24, but I have 2 partial products that I then have to add together at the end, giving me a total of 48. All right, so our last step here is we have 2 partial products in our standard algorithm that we need to put back together. So we have our ones place, tens, 100, 1,000, and 10,000. So 51,168 is our product for problem number 3. All right, that's all I have for you guys today. Make sure you double check your work, and I'll see you again soon. Bye.